Welcome back to Spring into Math 8. Today's lesson is a content review for Chapter 9. So we're going to be reviewing everything we've talked about so far in this chapter. The very first topic we talked about in Chapter 9 was input and output tables. So when you have an input and an output table, you can actually use that information and turn it into coordinates. And that's what it's showing you here. In blue, we have the inputs, or the x value. And in red, we have the outputs, or the y value. You can list ordered pairs by looking at input and output charts. So here we have the ordered pairs 0, 12, 2, 10, 4, 8, and 6, 6. Now I got these ordered pairs of these coordinates based on what I see here on my input and output chart. Input has values of 0, 2, 4, and 6, and output has values of 12, 10, 8, and 6. And so I pull that information out, and that's how I made my coordinates. Something you should know, though, is that the input 0 here on this input-output chart has two outputs. It actually shows the numbers 5 and 6 if you're looking at those arrows. And when you see this, you should know that this is not a function. Okay? When you see that input has two outputs, that means that it's not really a function. Topic 2 in Chapter 9, function tables, coordinates, and graphing. So we have here a function table, and the first thing we need to do is fill out our function table based on the operation they're asking us to do. Now here, this function table looks like they're asking us to multiply the x values by the number 4. So if I put -2 in there, I get -8. And if I put -1 in there, I get -4. And if I put 2 in, I get +8. And if I put 1 in there, I get +4. Now, these have been turned into coordinates for us. -2, -8, -1, -4, 1, 4, and lastly 2, 8. We can put these on a coordinate plane and graph them to see what this function would look like. So let's take a look at what it looks like. Now, I've only dropped 2 of those 4 points down here because my chart doesn't have a coordinate plane doesn't have enough space. But we've got a nice visual here of what function looks like when graphed. Topic 3, function tables. Now, we've had a little bit of practice at filling out function tables lately, but something we need to remember very often is that we have to think about the order of operations. So I have 2x plus 4, so I have multiplication followed by addition. Now, according to order of operations, we need to multiply first and then we add the 4. So 2 times 2 is 4, plus 4 more makes 8. -2 times 2 makes -4, plus 4 is 0. If I stick a 4 in there, I get 4 times 2 is 8, plus 4 more is 12. Put a 3 in there for the x value. 2 times 3 is 6, plus 4 makes 10. And if I put a 6 in there, 6 times 2 is 12, plus 4 more, it makes 18. Now, if we wanted to, we could take these and make them into coordinates and then graph them. But really, this section is just talking about learning how to fill in a function table. So again, a reminder, order of operations is key. In this case, we had multiply, then add. So make sure we pay special attention to that. Topic 4, comparing functions. We're going to look at comparing a set of functions here. And they're asking us which has a greater rate of change. Function 1 has y equals 3x plus 5. And function 2 is just listed in a function table. So function 1, we have y equals mx plus b format here, which is a nice, friendly, easy format to work with. So we know that the m value, or the number in front of the variable here, is always the slope. So in this case, it's +3. Now, function 2 just gave us some information, and we had to pull that out and make coordinates, and then stick those coordinates in the slope formula. So I used the coordinates -2, -4. And then I also followed up using the coordinate 0 and 2. When I insert those into the y2 minus y1 over x2 minus x1, I'm going to go ahead and get 2 over 2. And we simplify 2 over 2 and we get 1. So function 1, which had a slope of 3, has a greater rate of change than function number 2, which had a slope of only 1. Or we could say it was 3 times as big. Topic 5, linear and nonlinear functions. What is a linear function? Well, a linear function is a function whose graph is a non-vertical line. A linear function can be written in the format y equals mx plus b, where m is the slope and b is the y-intercept. But the most important thing we should notice is that variables cannot have exponents. So what is a nonlinear function? Well, it's an equation with a graph that doesn't create a straight line. So if it has some curves in it, if it has zigzags, it's really not a linear function. It's called a nonlinear function. And of course, we have an example here at the bottom where the variable has an exponent of 5. Now, that means we have a nonlinear function. Here's a little quiz to end the chapter review about linear and nonlinear functions. The first question we have, y equals 3x to the 6th power plus 2. Now, we see that exponent right there right away. That should be the big indicator that we have a nonlinear function. And lastly, we have y equals x plus 15. So we don't see a variable, so it's also in that nice, easy format, y equals mx plus b. When we see that, we know it's linear, and that's it for today, friends. I'll catch you next time in Chapter 10, which is we're going to continue our work with functions, but we're going to learn how to model them. See you later.